Okay, for chapter 3, I'm going to go over in this video 3 different types of proofs that you might need to know for the test. And then hopefully I'm going to go over solving systems of equations and then some other things that you might need to know from things you need to know worksheet. So what I'm pulling from is this is page 159. This is page 159 in your textbook. I'm going to do proof number 26 for you, and I'm going to narrow this down a little bit so you can actually see what I'm writing. Okay, so this is again page 159, and I'm going to do number 26. So number 26 says write a paragraph proof, which I don't want you to write a paragraph proof, basically to prove that the same side interior angles theorem works. So the first type of proof that you're going to see is you're either going to be using corresponding angles postulate. You're going to either be using alternate interior angles, alternate exterior angles, or same side interior angles. And based on what the proof is, that's going to decide which one you use. Remember, the corresponding angles is the mommy of the other three. From the corresponding angles postulate, we can then prove the alternate interior angles, alternate exterior angles, and same side interior angles, which is what we're going to do with this proof. We're going to use corresponding angles to prove that same side interior angle works. So let's see. Given R is parallel to S, so that's what these arrows indicate, I want you to prove that measure of angle 1 plus measure of angle 2 equals 180 degrees. So we can start off with our given. I'm going to put this right down here. Okay, so we have our given, and that's R is parallel to S. Now, if I tell you that those two lines are parallel, you can then use corresponding angles, because like I said, that's the mommy of the other one. So we're going to use corresponding angles, and in this picture we have corresponding angles, angle 1 and angle 3. So I'm going to say angle 1 is congruent to angle 3, because they're corresponding angles, and because when we have parallel lines, they're going to be congruent to each other. Okay, now I want to eventually prove that measure of angle 1 plus measure of angle 2 equals 180 degrees. So what that means is I need to get rid of this congruency sign. So I'm going to change it to measure of angle 1 equals measure of angle 3, and that's going to be called definition of congruency. All I'm doing is changing the sides, or angles, excuse me. Okay, so now I've used this one and I've used this one. Okay, moving right along. And somehow I need to add in 180 degrees, and I need to introduce measure of angle 2, and I need to get rid of or kill off measure of angle 3, because that's the only thing I've talked about, measure of angle 3 and measure of angle 1. So let's see here. What can I say is the relationship between angle 2 and angle 3? Well, to me, they look like a linear pair. So we're going to use the linear pair theorem. And I'm going to move this over like this. Okay, I'm going to make this a little bit bigger so hopefully you can see my writing a little bit better. Okay, linear pair theorem says that they're a linear pair, so they're supplementary. So angle 2 and angle 3 are supplementary. Then we're going to use the fact, well, since they're supplementary, that means that they've got to add up to equal 180 degrees. And what's the reasoning for that? Whoops, excuse me. Well, that's definition of supplementary. That's what the word supplementary means. So cool. So we have a linear pair. They're supplementary. That means they add up to be 180 degrees. Now I've introduced that 180 degrees into my story. Okay, so I've used this one. Now let's look at this step and this step. Well, if you notice, there's something similar that happens in both of them. They both have a measure of angle 3. So what we can do is we can kill off that character, and we can input measure of angle 1 for that character. So this one would now be measure of angle 2 plus measure of angle 1 equals 180 degrees, and that was just called substitution. All I did was kill off one character with another character. Now if we look back at our picture, angle 1 and angle 2 are added to be 180 degrees. This proves same side interior angles works. Hooray! So in the future we can use this in a proof. So if you notice, if we have parallel lines, we can say same side interior angles are supplementary. Hooray! And that's what they wanted us to do for proof number 26 on page 159. That's one type of proof you might have on your test. Another type of proof is on page 167. So if you go to page 167 in your textbook, you'll see another type of proof. So let's see, I'm going to scoot down all the way to 167. Sorry, this might make you a little dizzy. Not my intention, I promise. I think. No more. Okay, 167. Which one did I want? I wanted number 20. Oh gosh, 100. No, I'm sorry. I wanted number 55. Just kidding. Let's see if this is here. Ah, Jen. Keep going. Keep going. Just kidding. Too far. It's really hard for me to see, in my defense. Oh gosh. Okay. Almost. Almost. Good sports. Random fact. Let's see. Which should the random fact of the video be? I'm ridiculously good at Chinese checkers. Ridiculous. Okay. Goodness grief. Let's go faster. Okay, 55. Sweet. Here's a good one. It says, given measure of angle 2 plus measure of angle 3 in this picture equal 180 degrees, prove that line L is parallel to line M. Now, the second type of proof that you're going to see on this test is when you're proving lines are parallel. If you're going to prove lines are parallel, there's really 5 different ways, but 4 of them are most likely going to be. It's either going to be converse of corresponding angles, converse of alternate interior, converse of alternate exterior, or converse of same side interior angles. So you're going to have to probably use one of these in this proof somewhere. So let's see. 55, it says we're talking about angle 2 and angle 3, and you want to prove that line L is parallel to line M. So let's think about how can we maybe, looking at this picture, what do you think we could use? Well, we have angle 2 and angle 6 that we could probably, since angle 6 and angle 3 are vertical angles, we could probably say, well, instead of angle 2 plus angle 3, we could say angle 2 plus angle 6 have to equal 180 degrees. And if these equal 180 degrees are same side interior angles, so we can use the converse of same side interior angles to prove that the lines are parallel. So let's see if we can maybe put all that down into a proof. Okay, so we're going to start off with our given. Our given is that measure of angle 2 plus measure of angle 3 equals 180 degrees. That's our given. Sweet. And then we said in our picture that angle 6 and angle 3 are congruent by vertical angles. So our second step could be vertical angles. And we could say angle 3 is congruent to angle 6. Now again, we have congruent signs and the equal sign, so that means we're going to have to change it from a congruent sign to an equal sign. And that's just called definition of congruency. Some people are still putting definition of equality, and I'm telling you that doesn't exist. Okay. Now that we have equal signs, again, we can take off, see how this measure of angle 3 happens here and here? We can just substitute that measure of angle 6 in here. So now our new equation would be measure of angle 2 plus measure of angle 6 equals 180 degrees. Again, all we did was substituted. Okay, now looking at our picture. Measure of angle 2 and measure of angle 6. Those are same side interior angles, and we just proved that they're supplementary. They equal 180 degrees. So what we can say is we can say that those lines are parallel by the converse. Do not forget the word converse of same side interior angles. And then I think it was line L and line M. Yeah. So line L is parallel to line M. Okay, so it's the second type of proof you can see. Again, proving lines are parallel, you're going to be using a converse most of the time. The last proof I want to talk to you guys about is page 175, number 4. And this was on your assignments, one of your assignments. So page 175, number 4. Okay, here it is. Okay, so the second one, we're talking about perpendicular lines. Whenever you see perpendicular lines, there were 3 proofs, 3 different postulates or theorems that we talked about. One was perpendicular transversal theorem. One was deemed linear pair congruency theorem. That was deemed appropriately by Amanda. And then the last one was corresponding right angles. That was deemed by Jasmine, our lovely geometry gods. Okay, goddesses rather. Okay, so in this problem it says angle ABC is congruent to angle CBE. And then it says that DE is perpendicular to AF, which is why they have that right angle. And then they want us to prove now that CB is going to be parallel, that these two lines are going to be parallel to each other. Okay, so if we start off with the fact that these two angles are congruent to each other, one of these three theorems says that since these two angles are congruent, that these lines have to be perpendicular. Because if you think about it, again, this is a linear pair, and that means that they add up to be 180 degrees. And if these two are congruent, that means that these both have to be right angles. And that one is not perpendicular transversal, it's the linear pair congruency theorem, because we have a linear pair and each angle is congruent. So this one would be linear pair congruency theorem. Okay. Now if I tell you that DE is perpendicular to AF. So if you look at these two lines, right, we have, if you look at just these right angles, we have a pair of corresponding right angles. If these corresponding angles are congruent, that means these lines have to be parallel. And that's called the corresponding right angles theorem by Jasmine. Okay. And we have that written down on our notes. The perpendicular transversal theorem says that if you have two lines that are parallel, so you already know two lines are parallel, and if one of those lines is perpendicular to the transversal, well, that means that the other one has to be perpendicular as well. That's what the perpendicular transversal theorem is. So you should be sort of familiar on those three proofs. And it's already been 12 minutes. I know that's a long time. So I'm going to pause this video, and on the next video, I'll show you guys how to solve systems of equations if you're shaky on your algebra, and as well as go over a few of the things you need to know worksheets.